Water. It is a dwindling commodity and is a necessity for human life, vanishing ecosystems, and the ever-thirsty modern industry. Many industries such as manufacturing, data centers, power providers, and oil and gas plants require enormous amounts of cooling. Water has been one of the most cost-effective and plentiful options for industrial cooling in the last 150 years. Water is a vanishing resource, and more conservative options of cooling must be explored to achieve water security. Let's see how industrial water cooling systems work. First, cold water is pumped through piping to a contactor or vessel where it exchanges heat with the process that needs to be cooled to produce the desired product. Then the heated water is removed from the system to either be cooled back down to the desired temperature or removed from the system. The recooled water is returned to the exchanger, completing the entire loop. Now we will look at various cooling water options that are often utilized by industry and explore their strengths and weaknesses. One option is once-through cooling. This system is the simplest design. It works by withdrawing huge volumes of water from a river, lake, or aquifer, running it through equipment one time, and then discharging it back to the source at a higher temperature. According to sustainability analysis, once-through systems require very high water withdrawals, even though most of it is eventually returned to its origin. There are a few problems, however. They place enormous stress on local water bodies. They raise the river or stream temperatures, which can harm the ecosystems. And in drought-prone regions, they simply aren't sustainable. A second option for cooling is the open-loop cooling system. It allows the cooling water to be open and exposed directly to the air. The hot water returning from the heat exchanger is sprayed over fill media in a tower, while air is drawn through by large fans. A portion of the water evaporates, carrying heat away, and the remaining cooled water returns to the basin of the tower and is then pumped back through the system. Open-loop systems are very efficient at providing cooled water to be used in the process, but there are many drawbacks. Due to the evaporative process, the conductivity in the water can rise, causing serious damage to the piping. To mitigate this highly corrosive water, a portion must be constantly drained or blown down and refilled with fresh water, which puts excessive strain on the main water source. Water in this system is also open and exposed to dust, debris, and biological growth. These contaminants must be chemically treated. Due to the high chemical content in the treated water, what is drained can be toxic to the environment and must be disposed of properly. Although this system works well, the open-loop system consumes a significant amount of water and threatens the water security of local communities, especially those in drier climates. Finally, we come to the closed-loop cooling system. In these systems, the processed fluid, usually water, circulates inside a sealed coil. It never touches the outside air. Heat is removed either through air alone or by spraying a small amount of water over the coil to boost heat transfer. Here's why closed-loop cooling is the most desirable option for water security. First, there is much less water consumption than open-loop systems. Because the cooling fluid is sealed, water losses are minimal. A newly built AI data center in Abilene, Texas requires large amounts of cooling. They installed a closed-loop cooling water system. With this system, they only use a little over 12,000 gallons of water every year. This is roughly half of what a normal residential home uses in 1 month. There's also very minimal contamination risk. No airborne dust, algae, or debris enters the system. This reduces chemical use and extends equipment life. There's also greater reliability in drought conditions. Closed-loop systems maintain cooling performance even when the water supplies are restricted. This makes them ideal for regions facing water scarcity. Lastly, the closed system helps protect the ecosystem. With no draining and very few chemicals needed for treating, this system prevents used water from contaminating the natural rivers and streams. So let's look at these three cooling water choices side by side. Once-through cooling strains water bodies with massive withdrawals and can damage the wetlands by increasing the water temperatures. Open-loop cooling consumes vast quantities of water because of evaporation and blowdown. It also requires heavy chemical treatment and presents an environmentally toxic challenge. Closed-loop cooling reduces chemical treatment, protects water quality, and prevents excessive water consumption from the local water supply. In conclusion, closed-loop cooling allows industries to grow without draining the local rivers, lakes, and aquifers that communities depend on. It is the technology that aligns economic progress with environmental responsibility and provides water security for our future.